रेड शिक्षण संस्था सातारा रोज प्रोजेक्ट 2021-22 11वीच्या विद्यार्थ्यांसाठी हा रोज प्रोजेक्ट या अंतर्गत यशवंतराव चव्हाण इन्स्टिट्यूट ऑफ सायन्स सातारा आपण याच्या आधी रिडॉक्स रिएक्शन्स या चॅप्टरचे 2 लेक्चर्स घेतलेले आहेत. The next topic of this chapter that we have to study now. Up till now we have studied the oxidation reaction, reduction reaction, the classical ideas of oxidation and reduction reactions. Similarly, we have studied the oxidizing and reducing agents. Similarly, in terms of electron transfer, we have studied the oxidizing agent and reducing agent. Now, the oxidation number, again, we have studied the rules to assign the oxidation numbers. Now, next point of the chapter that we have to study is a stock notation. Stock notation. Now, the method of representing oxidation number of a metal by Roman numericals, that is 1, 2, 3, etc. within the parenthesis is known as stock notation. Again, I repeat this meaning of the stock notation. The method of representing oxidation number of a metal by Roman numericals. In Roman numericals 1, 2, 3, these are the oxidation numbers of metals, and they are represented by Roman numericals within the parenthesis. And this method of representing the oxidation number, that is known as a stock notation. So by stock notation, we can understand the oxidation number of metal in a compound. The oxidation number, how to find out this oxidation number, we have studied different rules to find out the oxidation number of metal. Now, there are some elements which are having the fixed oxidation numbers. For example, fluorine, it has a 1- oxidation number. Halogens, chlorine, bromine, iodine, they have -1 oxidation number. Similarly, alkali metals have +1 oxidation number. Alkaline earth metals have +2 oxidation numbers. We have studied these rules to assign the oxidation numbers. In stock notation, the oxidation number of a metal is represented in Roman numericals in parentheses. For example, let us write the stock notation for this FeCl2. FeCl2 is a ferrous chloride. In this compound FeCl2, Fe, iron, is a metal, and chlorine is a non-metal. Chlorine is a non-metal, and this ferrous chloride, this is a compound. Now, in case of ferrous chloride, the stock notation can be written according to the method as already we have explained. That is representing oxidation number of metal by numericals, Roman numericals, 1, 2, 3, etc. within the parenthesis. And this is called as a stock notation. So for FeCl2, iron, ferrous chloride, the oxidation number of iron that we have firstly to find out, and then we can write the stock notation of this compound. या कंपाऊंडचं स्टॉक नोटेशन लिहिण्यासाठी आपल्याला आयर्नचा ऑक्सिडेशन नंबर पहिल्यांदा माहित असला पाहिजे. तो पहिल्यांदा काढायचा. तर तो कसा काढायचा आपल्याला माहित आहे. आपण शिकलेलो आहोत की ऑक्सिडेशन नंबर ऑफ हॅलोजन्स इन देअर कंपाऊंड्स इज ऑलवेज -1. So chlorine has oxidation number -1. In FeCl2, the oxidation number of Cl is -1. And since there are 2 chlorine atoms, -1, -1, -2. So in FeCl2, ferrous chloride, the oxidation number of iron will be 2. It is because there is no charge on FeCl2. And therefore, the oxidation number of iron is 2 in ferrous chloride. And therefore, the stock notation of this compound can be written as iron, and the oxidation number is written in a bracket. Oxidation number of iron is 2. So iron 2 chloride is a stock notation for FeCl2. म्हणजे FeCl2 चं स्टॉक नोटेशन कसं लिहिणार? आयर्न 2 क्लोराइड. 2 आहे काय? तर त्याचं ऑक्सिडेशन नंबर आहे. आता आयर्नचा ऑक्सिडेशन नंबर 2 कसा आला? तर क्लोरीनच्या ऑक्सिडेशन नंबर वरून काढ. कारण क्लोरीनचा ऑक्सिडेशन नंबर -1 असतो. 2 क्लोरीन आहेत म्हणून -2 आणि म्हणून आयर्नवर 2 अधिक 2 हा त्याचा आयर्नचा ऑक्सिडेशन नंबर आला. म्हणून आयर्न इन ब्रॅकेट 2 क्लोराइड इज अ स्टॉक नोटेशन फॉर FeCl2. Similarly, let us take another example to write the stock notation. Because this system was introduced for the first time by German chemist Alfred Stock. And therefore, this method, this system is known as stock notation from the German chemist Alfred Stock. This name, that is stock notation, it is written. For example, in FeCl3, the stock notation for this FeCl3 can be written as, firstly we have to find out the oxidation number of metal. In this compound, FeCl3, iron Fe is a metal and chlorine is a non-metal. So metals have variable oxidation states. Especially the D block elements have variable oxidation states. Iron is a D block element. We know iron, cobalt, nickel, copper, these are D block elements. So iron is one of the elements present in D block. So the oxidation state of iron in FeCl3, it will be, for 1 chlorine there is a -1 oxidation state. So there are 3 chlorine atoms. So oxidation state will be 3-. And therefore the oxidation number of iron will be 3. Isn't it? And therefore, the stock notation of this FeCl3 can be written as iron in bracket 3 chloride will be the stock notation of FeCl. 3 indicates the oxidation number of iron. So iron 3 chloride is a stock notation for FeCl. Similarly, let us consider KMnO4, potassium manganate. It is a KMnO4. In case of KMnO4, the K potassium is an alkali metal, first group element, and its oxidation number is fixed, +1. Similarly, oxygen, its oxidation number is again fixed, that is 2-. So the oxidation number of Mn, manganese metal, that oxidation number that we have to firstly find out. And then accordingly, we can write the stock notation for KMnO4. So for potassium, there is a +1 oxidation state, and oxygen, there are 4 oxygen atoms. So 4 multiplied by -2, that will become -8. So -8 for potassium, there is a +1, that will become -7. And therefore, the oxidation state of Mn will be +7. So manganese, that is, it is a metal, and its oxidation state will be 7. And therefore, the stock notation for this compound KMnO4 can be written as potassium manganate 7. That is potassium manganate in bracket 7. This will be the stock notation of KMnO4. Now, let us consider another example to write the stock notation. CO, cobalt, CONH3,6, 3+. This is an ion, hexamine cobalt, 3+. In this compound, the oxidation number of cobalt we have to find out. In case of, this is a coordination compound. So the NH3 has a 0 charge, and therefore the oxidation number of cobalt will be the charge on this ion. So CONH3,6, 3+, the oxidation number of cobalt CO will be 3+. So oxidation number is 3, and hence the stock notation of this compound can be written as hexamine cobalt in bracket 3. So hexamine cobalt 3 ion is a stock notation. Therefore, from this much information, we can say that the stock notation is used to specify the oxidation number of the metal. So oxidation number of metal is written in a bracket. So we specify the oxidation number of metal in a compound. So या स्टॉक नोटेशन मध्ये ब्रॅकेट मध्ये जे लिहिलेला अंक असतो, रोमन न्यूमेरिकल जो असतो, तो काय असतो तर त्या कंपाउंड मधला जो मेटल आहे त्या मेटलचा ऑक्सिडेशन नंबर असतो. That is represented in a bracket, and accordingly the stock notation is written. Okay, now with these examples we have studied the stock notations. That is FeCl2, FeCl3, KMnO4, and a cobalt, hexamine, cobalt 3 plus ion. We have studied the stock notation. Now, next part of the chapter that we have to study is a redox reaction in terms of oxidation number. Redox reaction in terms of oxidation number. Now, consider this reaction, which is a redox reaction. That a reaction is hydrogen when combines with oxygen, it forms water. That is twice of H2 gas plus O2 gas gives twice of H2O liquid. In this case, hydrogen has oxidation number 0 and it changes to positive oxidation state in H2. So 0 oxidation state of hydrogen changes to positive oxidation state in water. While in case of oxygen, the oxidation number changes from 0 to di-negative in H2O. That means oxidation number of hydrogen changes from 0 to positive, whereas oxidation number of oxygen changes from 0 to di-negative in H2O. So it is assumed that there is electron transfer from hydrogen to oxygen and hydrogen is oxidized and oxygen is reduced because hydrogen has lost electron. That is why its oxidation state changes from 0 to plus positive, whereas oxygen has gained the electrons, and that is why its oxidation state changes from 0 to di-negative in water. Now, let us consider the types of redox reactions. There are mainly different types of redox reactions. First one is a combination reaction. For example, carbon combines with oxygen producing carbon dioxide. कॉम्बिनेशन रिएक्शन म्हणजे यामध्ये काय होतं तर कार्बनची रिएक्शन ऑक्सिजन बरोबर होते आणि कार्बन डायऑक्साईड तयार होते. म्हणजे कॉम्बिनेशन आहे, कार्बनचं आणि ऑक्सिजनचं कॉम्बिनेशन होतं आणि कार्बन डायऑक्साईड तयार होतं. सो कार्बन इन अ सॉलिड स्टेट when reacts with oxygen in a gaseous state produces carbon dioxide. We know ज्यावेळेला कार्बन हवेमध्ये बर्न होतं, कंबशन होतं त्याचं. So combustion reaction takes place in presence of oxygen. Therefore, carbon when reacts with oxygen gives carbon dioxide. So this is a combination type of reaction. Similarly, methane gas when it burns. So burning process takes place with oxygen. So methane CH4 gas plus twice of O2 gives CO2 gas plus twice of H2O liquid. Again, this is a reaction of combination type. So this is combination redox reaction. This is a redox reaction. Methane reacts with oxygen gives carbon dioxide and H2O. This is a redox reaction. And this is a combination type of reaction. Now take a second type of the reaction, that is a decomposition reaction. Decomposition is the breaking of the larger molecules into the smaller one. This reaction is called as a decomposition reaction. Here it is given the example H2O liquid on decomposition gives hydrogen and oxygen. The reaction can be represented as twice of H2O is equal to twice of H2 plus O2. So decomposition of H2O takes place. Again, this is a redox type of reaction, because hydrogen has gained electron and oxygen has lost electron. In H2O, the oxidation number of hydrogen is +1, whereas in H2 molecule, the oxidation number becomes 0. That means hydrogen has gained the electron, isn't it? So +1 changes to 0, whereas oxygen in H2O has 2 minus oxidation number, and it changes to 0 in O2 molecule. So -2 changes to 0. That means the electrons are lost. So there is a gaining and losing the electrons. Therefore, this is a redox reaction, and this is a decomposition type of reaction. Similarly, sodium hydride on decomposition gives sodium solid plus hydrogen gas. So this is a decomposition type of reactions. Now, आता तिसऱ्या प्रकारची रिएक्शन रिडॉक्स रिएक्शन आपल्याला पाहिजे ती म्हणजे डिस्प्लेसमेंट रिएक्शन्स. डिस्प्लेसमेंट, one metal displaces the another metal on reaction. For example, metal displacement reactions. Consider the reaction CuSO4 aqueous plus zinc gives zinc SO4, zinc sulfate aqueous, ZnSO4 plus Cu solid. From CuSO4, copper is displaced by zinc, forming zinc sulfate, ZnSO4. Therefore, this is a displacement type of reaction, and it is also a redox reaction. And the fourth type of the redox reaction is a disproportion reactions. Disproportion reaction. This point, types of redox reactions, we have taken from the NCERT book. Remember this. In your textbook, this type of reactions are not given, but this is a NCERT point. NCERTच्या पुस्तकामध्ये ह्या टाइप्स ऑफ रिडॉक्स रिएक्शन्स दिलेले आहे, तर तो पॉइंट ऍडिशनल आपण घेतलेला आहे ज्यादा माहितीसाठी तुमच्या. चौथी रिडॉक्स रिएक्शन्स कोणता प्रकार आहे? The types of redox reaction, the fourth type is a disproportion reactions. The decomposition of hydrogen peroxide is a familiar example of this type of reaction. Disproportion reactions. That is, twice of H2O2 aqueous gives twice of H2O liquid plus O2 gas. This is a disproportion type of reaction. Disproportion type of reaction. Here, from H2O2, the oxidation number of oxygen is -1. It changes to -2 in H2O and 0 in O2. So this is a disproportion type of reaction. This is disproportion type of reaction. In hydrogen peroxide मध्ये ऑक्सिजनची ऑक्सिडेशन स्टेट ही -1 असते. एक्सेप्शनल एक्झाम्पल आहे. इतर कंपाऊंड्स मध्ये ऑक्सिजनची ऑक्सिडेशन स्टेट -2 असते, परंतु हायड्रोजन पेरॉक्साइड मध्ये -1 असते. सो इन हायड्रोजन पेरॉक्साइड aqueous on decomposition gives H2O. तर H2O मध्ये ऑक्सिडेशन स्टेट ऑक्सिजनची ही -2 असते, म्हणजे -1 ची -2 मध्ये झाली रिएक्शन. ऑक्सिडेशन स्टेट -2 झाली. त्याचप्रमाणे O2 मॉलिक्युल फॉर्म झालेला आहे, आणि O2 मॉलिक्युल मध्ये ऑक्सिडेशन स्टेट ऑफ ऑक्सिजन इज 0. So twice of H2O2 aqueous gives twice of H2O लिक्विड प्लस O2 गॅस. ठीक आहे. तेव्हा आपण स्टॉक नोटेशन म्हणजे काय हे पाहिलं, वेगवेगळे एक्झाम्पल्सचा अभ्यास केला, स्टॉक नोटेशन्स. त्याचप्रमाणे रिडॉक्स रिएक्शन इन टर्म्स ऑफ ऑक्सिडेशन नंबर याचा अभ्यास केला. हे ऑक्सिडेशन नंबर वरून रिडॉक्स रिएक्शन हे समजून घ्यायची. हे ऑक्सिडेशन नंबर चेंज होतो. ऑक्सिडेशन नंबर चेंज झाला याचा अर्थ ती रिएक्शन कशी आहे, रिडॉक्स रिएक्शन. त्याच पद्धतीनं आपण टाइप्स ऑफ रिडॉक्स रिएक्शन्स पाहिले. त्यामध्ये 4 टाइप्स आहेत. पहिला कॉम्बिनेशन रिएक्शन्स, दुसरा डिकम्पोजिशन रिएक्शन्स, तिसरा डिस्प्लेसमेंट रिएक्शन्स, अँड द फोर्थ टाइप, चौथा टाइप कोणता आहे, डिस्प्रपोर्शन रिएक्शन्स. ओके. सो इथं आपल्याला हा तिसरा पिरियड आपण कंप्लीट केलेला आहे, टाइप्स ऑफ रिडॉक्स रिएक्शन. ओके. ओके.